Alright, this should be fun. We're going to look at the basics for understanding the definition of a limit, which is often a struggle for first year calculus students. So we'll establish some terms and things like that here to get us comfortable with some ideas. The first thing I want to talk about is image. For example, I have a graph of a function over here. We're not concerned with what the function is, but let's say that if x is something like -3, of course that would correspond to this point on the graph, which would then give us a y value over here. Let's say that that is maybe a little bigger, like 3.2. Then what we could say is these guys here are there's a special relationship here. Of course, -3 is x, 3.2 is y, or the function value. -3 is the input to this function, and 3.2 is the output. But also, the image of the input -3 is 3.2. Okay, so the image is the output. Also, you could do this with a set of numbers. So let's say we look at some x values that are in a certain interval here. All of these x values here in this interval from this first number to the second number. I'm not concerned with what the numbers are. I guess we could label them if you want. Let's maybe call this -3 and this -2. So we could look at the image of that interval now, the image of that set. The image of the interval -3 to -2 is, and the way you determine that is by sort of mapping through your function here to get those corresponding outputs. This interval, your y interval here, the output interval, would be your image. So let's say that that is something like 2.2 to 3. So the image of this set or this interval is this set or this interval, 2.2 to 3. So you can take the image of a single input, or you can take the image of a set of inputs and manage that. Next, I want to look at lowercase delta, the Greek letter delta. It's kind of like D, but instead of a D, you sort of curve around like this. So lowercase delta. Lowercase delta usually represents a small value, a small positive number, something close to 0. So we'll usually see this notation: delta is greater than 0. Delta in mathematics, you might see uppercase delta looks like this. It means the difference. That's sort of where this comes from in this example with the definition of a limit as well. It's going to represent a difference. Okay, so delta is a small number. Epsilon is another Greek letter that is also another small positive number. Now remember, epsilon was used, this looks like an E for error, a word in another language that means error, and that's what this is going to represent. Now let's talk about neighborhood, a mathematical neighborhood. If you look at a number line, and let's call this a number 2, we could look at what's called a delta neighborhood of 2. So what that means is, let's say for example delta is the number, a very small positive number, so maybe like 0.1. The delta neighborhood would be every number within 0.1 unit of 2. So if I go to the right 0.1, I'd end up at 2.1. If I went to the left 0.1, I'd end up at 1.9. Every number in this interval is in the delta neighborhood. Of 2. In other words, it is the interval 1.9 to 2.1. You could also call this an epsilon neighborhood maybe. If this was epsilon, then it would be called an epsilon neighborhood. So a neighborhood is just basically centered at the value you're discussing, in this case 2, and you measure your small positive value in each direction to get your neighborhood. Every value in that interval is in the neighborhood. These things can be described like this also. So another way to write this interval might be in terms of the center of the interval 2. Instead of writing 1.9, I might write that as 2 minus 0.1. Instead of writing 2.1, I might write that as 2 plus 0.1. And of course 0.1 was our delta, so I could call this 2 minus delta and 2 plus delta. You could see that 2 would be the halfway point between these two values. So one is delta more than 2, one is delta less than 2. Now if I want to say x is in this delta neighborhood, I could write x is an element of, that's what this symbol means, this set. Another way to write this is equivalent, so I'll use equals with a congruent sign over the top, and that's kind of hard to write vertically. Sorry, let me slow down on that. These two things are equivalent. The distance between x and 2, right? What I'm wanting to see is any x value in here, maybe this guy, the distance between x and 2 will be less than your delta, right? Less than 0.1 in this case, no matter what x you choose. If you choose this x, the distance between x and 2 would be less than delta. Well, the way to measure a distance is by taking the absolute value of the difference. X minus 2 is going to tell you how far apart those two things are. Absolute values are going to make sure that's a positive distance. So the distance between x and 2 would be less than delta. So if x is in the neighborhood, it could be written like this, an element of the set, or it could be written using absolute values. Those are equivalent to one another.